Good evening. I'm Matt O'Donnell, Dean of the College of Engineering at the University of Washington. This is going to be a lot of fun tonight. So there was an event today that happened which is actually related to part of the topic tonight. And let me start with a question. Do you know of a particular flight that happened today in which the price for a first-class ticket, or at least what was paid for a first-class ticket, was $30,000 for a flight from Tokyo to Hong Kong? Does anybody know what that flight was? The first Dreamliner where I guess somebody actually paid $1 to be on there. It's quite a striking event, quite a transition, and something that people in the Puget Sound area are applauding all over. So I think it's a great context to get into tonight's topic. And it's also a great piece for us because when we see the 787 up there, we realize how many UW engineers were involved in getting that off the ground. And the collaboration we've had between the university and the Boeing is strong, and we're hoping will become stronger over the next few years. We're thrilled to welcome our speaker tonight, who is Mary Armstrong. Her title's there, Vice President, Environment, Health, and Safety. That's very nice that she has those titles, but what we really care about is she's a Husky engineer, having graduated in chemical engineering in the late 70s. Tonight she joins us to talk about how Boeing is working to shrink their carbon footprint and their impact on the environment through engineering innovations, both in the air and on the ground. Please join me in welcoming Mary Armstrong. Okay.
Well, thank you. Thank you so much, Dean O'Donnell, and thank you all, alumni, students, friends. It's really great to be here tonight. Wonderful facility. And it's a real honor, actually, to get to kick off the engineering lecture series for 2011, especially in the light of the fact that we're celebrating the University of Washington's 150th anniversary. So fantastic honor for me. So like many of you, I attended classes here, right here at Kane Hall, but I have to say that this part of the campus was not necessarily the most comfortable spot for me. See, I went to the University of Washington to study chemical engineering. And I was thrilled to meet the Bensons here tonight. So I love Benson Hall, and that's where I like to spend my time. I'd wander to Bagley, and I might get even over to the Hub occasionally. But the people that I thought hung out at Kane Hall were really a completely different crowd than those of us who were into the numbers. And it was more of a crowd who was into, well, I wasn't quite sure what they were into, because as Dean O'Donnell said, I went to school here in the 70s. And you could find this same group of people outside of Kane Hall right here at Red Square. And they were a group with tie-dyed shirts and Birkenstocks, and they were playing hacky sack. The few classes that I really took on up here at the North End were these very few, you engineers know, very few non-engineering classes that we were required to take to kind of round us out. And things like psychology, even though I learned a lot, and I did. I learned a lot in these classes, and I have applied them quite a lot. I have a couple of members of my team in the audience, and I'm psychoanalyzing them all the time. But really at the time, these were the necessary evils for us in order to get an engineering degree at the University of Washington. So my challenge tonight is for us to, at least virtually, transport ourselves from Kane Hall and the north end of Red Square to the south end of Red Square in the center of the engineering department at the University of Washington. All right? So aerospace and the environment. Some people might not think that that is a likely combination. In fact, some people might think that is an oxymoron. And the title of this lecture series actually implies that there might be some difference in the environment and aerospace. But my focus tonight is to show you that the environment has always been center stage in the aerospace industry. In fact, it's always been part of our DNA since the start of the industry. Now I'm going to show you a very brief video to illustrate this. And that 30-second video, you just witnessed the most significant innovations and changes in the aerospace industry over the last 50 years. We've gone from 4-engine airplanes that literally gulped thousands of gallons of fuel, emitted tons of carbon, particulates, and soot, roared at ear-splitting decibels, and didn't really fly that far or that fast, to what today, and you just saw, the 6th generation of airplanes, twin engines that basically, comparatively, sip fuel, whisper quiet, and have a significantly lower carbon footprint, and can connect any 2 cities across the globe. So that truly is real environmental progress. And those aren't the words as those of you in the audience know. How many of you folks are from Boeing? Lots. So the kind of words we use in terms of traditional payload, range, meeting mission requirements. So if we strip away that engineering jargon, it really means that we can fly farther, faster, with less fuel, lower carbon footprint, and much more quietly. And we can deliver business value and solve the problems that our customers have in terms of meeting their customer demands, and that's the flying public. So that's what we've accomplished over the last 50 years before we've even started talking about how we will meet the requirements for sustainable, responsible growth in the aviation industry over the next 30 years. So meeting that goal of sustainable growth is going to take outstanding design and engineering, something that has been a cornerstone of aviation since day one. So these are the criteria that we're asking all of our Boeing engineers as they design our products, our parts, and our processes for the Boeing company. So by focusing on these things, global emissions, energy, they go hand in hand, water, hazardous materials, sustainable materials, noise, and local emissions. Engineers are driving new solutions and a sustainable growth and sustainable future for aviation. These positively affect our whole value stream. So we're talking about the factories that our suppliers operate, the factories that we at the Boeing Company operate, as well as those airplanes that you saw videos of and first revenue flight today, the 787, that we fly around the world. So I'm going to talk about what we're doing in this life cycle approach, and I'm going to start talking about the left side of this. And this is really about what we do in our factories and how we support and help our suppliers in their factories. So when I assumed my job, got the phone call nearly 4.5 years ago, the first area that we targeted was our own internal footprint, and we knew that we needed to commit to internal performance targets around energy, greenhouse gas, water, hazardous waste, and waste to landfills. We needed to walk the talk inside our own factories before we can expand outside. And we needed to treat environmental targets as if they were the same as business performance targets. And we're doing pretty well. So here are some stats associated with where some of these metrics, these reduction metrics that represent the most significant part of our environmental footprint have gone over the last few years. So since 2002, we have, and so this would be an efficiency improvement, so normalized to our revenue swings. We've reduced our CO2 emissions as well as our energy use, they go hand in hand, at our U.S. operations by more than 30%. We've reduced our hazardous waste generation and our water use by over 40% in that time frame. So we've accomplished those things with some significant engineering design, as well as some common sense engineering approaches to some of our facilities issues. So I'm going to show you a quick video next. Now the star of this video, also a UW alum, 2005, Chris Rowe, 2005 mechanical engineering graduate. And he's going to talk about an issue that's really very close to my heart, in that in my most of my roles at Boeing have been associated with managing facilities operations.
With the largest building in the world by volume, surrounded by a host of other buildings, you can imagine why Boeing's campus in Everett, Washington uses a lot of energy.
Yeah, we spend millions of dollars here every year to keep lights on and keep buildings warm, and it really adds up.
For Chris Rowe, who leads the conservation efforts here, the giant size is a challenge and an advantage.
There's always a new opportunity where you turn in different buildings, different systems.
Recently, Chris and the team started a project in the main factory where workers build the 777 and other large jets. The target? The more than 5,000 overhead lights. Many of them are near skylights in the ceiling.
Yeah, we had a lot of employee feedback, a lot of emails saying, hey, we see a lot of natural light, why are the lights still burning? And so we decided, hey, it's a great idea, let's see if we can make a change.
Electricians attached a light sensor to a few lamps near a skylight.
This is just a switch. It senses light, it switches.
Sure enough, the lamps automatically turn off during the day.
So now we're going to be expanding and basically carrying the same thing over through all the skylights in the factory, all 30.
The same idea was applied to another pilot program inside a parking garage. Here, the lights stay dim until motion triggers a sensor.
Before, the lights were on 24/7 at 200 watts. Now, at nighttime when most of the cars are gone, it's just a 17-watt bulb.
To make heating and cooling all the buildings more energy efficient, the team upgraded the motors that control the air intake. Now, Chris can monitor the system from his laptop and make immediate adjustments. In 2009, these and other efforts helped save 3 million kilowatt hours of energy here, enough to power 270 U.S. homes for 1 year. And that's just in Everett. Across the Boeing company, the savings added up to 10 million kilowatt hours. To be sure, not all ideas pan out. The Everett team installed gears inside 2 escalators to try to use less electricity. The numbers just came back and it didn't save much. But for Chris, it's all about taking little steps toward the bigger goal.
The more that we can reduce our environmental footprint, there's certainly a cost benefit there. So we're trying to seek out opportunities that really are a double win.
So now we're going to show you how we take a big design change and apply it at equal scale. So at our Charleston facility, which of course we're in our final phase of building a final assembly facility there, we've put a 10-acre photovoltaic solar power generating facility on the roof, which is equivalent to 20% of the power required at that entire site. We want our facility to represent the environmental progressiveness that the product that comes out of the facility, the 787, represents to the industry. So we've also engaged with the local utility and arranged to have the additional 80% of the facility covered through renewable power, with a renewable power contract. Now we've found ways for us to look at this over a life cycle along with the utilities so that there is no net increase. This is not more expensive to us over the life cycle, and it's these creative partnerships that marry engineering and our utility partners that have allowed us to go forward with this. Now, across, we have 4 other Boeing sites that are leading the way in terms of zero waste to landfill, where we have recycled, reduced use, looked at ways to take waste streams and generate electricity, and they're now sending no waste to the local landfills. And we've got many other facilities working in that direction. So as a result of all these efforts, the U.S. Environmental Protection Agency awarded Boeing the Energy Star Partner of the Year award, something that we're extremely proud of at the Boeing Company. So besides taking credible action, these environmental footprint reductions drop right to the bottom line for the Boeing Company. So environmental progressiveness and environmental forward thinking are good business practices at Boeing. So we marry the two, and hoping that we'll have some questions at the end of this that'll talk a little bit about how we have to look at the business and integrate environmental thinking into how we run the business in order for it to be sustainable. So we're taking those savings, and what do we do with those? We drive those savings into new research and technology to be more competitive, to derive new products like the 737 MAX that we've just announced, and I'll talk a little bit more about that lately. So again, being environmentally responsible is good for business. Okay, driving environmental thinking into our business, we also have to think about the areas of our sites where past practices have added contamination to the area, including the soils, the water, the stormwater, groundwater. So my team includes about 30 geologists and engineers who use the latest research and scientific technologies to clean up these remediation sites. And we have currently about 69 remediation sites throughout the company. So the picture up on the right is Carl Bach, your right. He is one of my environmental engineers, and he's a cougar, but we don't hold that against him. Carl's holding a jar of food-grade sugar syrup. And so what science tells us is if we take that sugar, it will accelerate bacterial growth and special bacteria that cleans up chemicals in soil. So we're injecting the syrup, which is a byproduct, by the way, of a beverage company here in the Puget Sound area, something they would throw away. And so it's accelerating the bacteria in the soil, cleaning up, and then allowing us to clean up the sites and result in a real harmless byproduct of that. But we're using this approach at several sites in the Puget Sound as well as Plant 2, and I'm going to talk a little bit more about Plant 2 in a minute. So the neat thing about the picture on the bottom is that's a former garbage dump, a former landfill in Wichita that we sent some of our landfill to. So this is a good example of what some of our latest technologies in remediation are really following Mother Nature and patterned after nature's natural cleanup capabilities. So part of this cleanup this site involves pumping a lot of groundwater that we first clean and then we pump out and pump it to the sewer. We're using wind energy to pump that water at about 1,000 gallons per day. But we also have about 20 cottonwood trees on this same site, and those cottonwood trees will treat and remove 10,000 gallons per day of this water. So it's a really great activity. It's a great way to use nature's natural processes, and it's something that we might talk about the triple bottom line. It's really good for the environment, it's really good for the community, and it's great for business. So this is a kind of guiding principle that we're using on something that's a little bit more close to home, and that's the Duwamish Waterway. So how many of you recognize this site? And what is it? Plant 2. Right. Okay, so Plant 2. This happened to be when I started at the Boeing company in 1984 as an R&D engineer. My first project was at Plant 2, and it looked a lot like this, except I don't know if you can tell, there's a few windows broken here, but the windows weren't broken back then. But this is a picture taken about 1.5 years ago. Now, I have always been incredibly impressed with what went on at Plant 2, particularly during World War II, where we turned out B-17s out of this factory. Now, the primarily female workforce at Plant 2 during that time set a record that still stands today for airplane production, in that there were, how many B-17s came out per day? Anybody know? 16 B-17s per day. So right now, our highest airplane rates are something like 32 a month on the 737 in Renton. So 16 B-17s a day. Incredible. And we built about 7,000. And again, that was a mostly female workforce. Still stands today. But as one of the first environmental engineers and as a facilities director at this site over the course of my career, I also knew what kind of processes that we'd use that were common and acceptable practices in the past, and knew what we needed to do to clean the facility up. So here's that same view, but from the top. So you can see how big this facility is. It's 1.2 million square feet. This is a year later. So we've demolished, as you can see, we've demolished most of the facility. I'm going to show you one more picture. But this was one of the largest airplane manufacturing facilities of its time. So there's tons of debris, concrete, steel, wiring, old wood, cool wood floor beams. By doing some careful planning in advance, we were able to recycle 85% of the debris that came out of that facility. So here's the very last one. We have a really cool video on Boeing News Now where this last one comes out. And now you can stand in the parking lot and you can see Mount Rainier and you can see the Duwamish, which is what that building overhung. So over the next couple of years, we're going to remove about 200,000 cubic yards. That's about 4,000 rail cars worth of sediment out of that waterway, and reconstruct about a half a mile of habitat for salmon, migrating salmon and other migrating fish. So I've been talking about what we've been doing at our facilities. We're also moving upstream into our suppliers' facilities. So it used to be that you required 3 things of a supplier at the Boeing company. And since I used to run the fabrication division, I was the internal supplier. It was 3 things. Got to get parts there on time, can't have any defects, and they need to meet unit cost. So that's what we expect our suppliers. We added a 4th criteria last year, and we said, you also must have a robust environmental management system, and we need to have proof of that as we continue to partner with you. We've also gone into this with the suppliers, and again, as I mentioned, it's good business to reduce our environmental footprint. It's just waste. We've helped the suppliers look at ways to reduce their energy consumption using some of our tools, and a lot of our suppliers actually know a lot about reduction themselves, so we've learned from them. But there's an enormous amount of packaging that goes on when you have 4 million parts going into a 6-7 or thereabouts. A lot of those are packaged up. So working together, we eliminate a lot of cost, and then we're able to split that with the supply base. Okay, now I'm going to move to the other side of this, and the rest of my remarks will be focused on what's going on in the airplane arena, what's going on with our products, and how are we working as those products come out of their useful life. So why does the aerospace industry have such an intense focus on our carbon footprint? This is really the reason. The commercial aviation industry emits 2% of man-made carbon annually. So 2% doesn't sound like much, but it includes, it's as big as the entire computing footprint for carbon emissions. It's bigger than many countries. And we're happy about this. Aviation is growing. There's a big demand for airplanes. So we're growing at about 5% a year, which means over the course of the next 20 years, by 2030, thereabouts, we could double or increase between 50 to 100%, so up to about 3% of the total carbon footprint of the world. So I mentioned earlier, if we are going to grow in a sustainable manner, in a responsible manner, we have to figure out how we do this in reducing our carbon footprint and the other environmental footprints we have associated with airplane growth. So the commitment that our industry has made is that we will be carbon neutral growth by the year 2020. That means that even as we are building more and more airplanes, we are going to, using technology, we are going to grow in a carbon neutral way. So I'm going to show you now what the three elements of our strategy is. Obviously, things like the 787, the 747-800, 20% and 16% more fuel efficient, therefore more carbon efficient than the airplanes that will replace. Second piece, the airplane operates in a system. So replacement of old antiquated air traffic management systems. And I'm going to talk a little bit about that. And the final piece, which is really 50% of the opportunity and something that is required for sustainable growth for aviation, are sustainable drop-in biofuels. Fuels that we can drop right in that have a much lower carbon footprint than petroleum-based fuels across their life cycle. So we're going to talk a little bit about that, and we're actually going to see a video about that too. So biofuels represent one of the biggest opportunities for innovation and for engineers to develop new solutions. I mentioned these. We just announced the 737 MAX. We will deliver those airplanes about in the year, the 2017 timeframe. So that airplane will have between a 10 and 12%, so really in the early design phases of lower carbon footprint than the 737 next gen, so the 8s and 9s that will be replacing in the fleet. So fuel represents the largest what for an airline? Largest single operating expense for an airline. And how profitable are most airlines? Marginally profitable. So when Boeing and Airbus offer new airplanes that have 15 to 20% more efficient fuel, there's a real economic incentive, right, for airlines to replace those old gas guzzlers with our new technologies. So this is another kind of connection that I want you to make, that environmental improvements are really foundational and fundamental to the whole operating model, given that fuel operating cost of the business. So over the next 20 years, do we have a guess on how many new airplanes the world's going to need? No, and Boeing people, you cannot say this if you know the answer. Oh, that is very good. It's actually almost 34,000, give or take 500 or so. So that's a lot of airplanes, right? About 40% of those airplanes are going to replace existing airplanes that are after their useful life, so they go out of service. So 40%. That means 60% of those airplanes are going to be brand new airplanes, growing the footprint for aviation. So if we think about the math behind these projections, even though the average carbon footprint, right, goes down, the overall, like I told you, the 2% to 3% increases. So that's why we're focused on making environmental improvements across the entire system. And just so you don't think, I'm putting a plug in for the November 9th presentation, of which we have our guest speaker here. Raise your hand, Tim. So Tim Venipol, my colleague on the environmental side, is going to talk about what we're doing on the military side. So this is the Phantom I, and it's a really cool airplane and that we're putting together down in California. And it's powered by hydrogen. So the other one is the X-48 unmanned solar-powered blended wing airplane that we're also looking at and studying the aerodynamics in order to drive those into newer editions of commercial airplanes. So these will probably be decades off, but we're investing in that kind of technology as well as things that are more near term. So speaking of near term, this is the air traffic management system and kind of showing you what goes on in terms of what we normally fly. So this kind of step down approach. About 12% of the fuel that the whole airplane system uses around the world is estimated to be wasted. 12% wasted because of inefficient air traffic management systems. So I'm sure that we all have experienced this, flying around. I know I go to Chicago all the time, flying to Heathrow, flying anywhere. You get in a pattern and it seems like it takes a long time. You're wasting your valuable time, but we're also wasting a whole bunch of fuel. So how many of you have cell phones in here? How many don't have a cell phone in here? Oh, okay, 3 or 4. Do you have GPS satellite navigation on your cell phones? Many of you do, right? So our airplanes are equipped with GPS navigation technology, right? It's common. But that is not how the current air traffic management system operates. It's 1950s technology, and it requires airplanes to hopscotch across their routes going from beacon to beacon. Not very efficient. So we're working with the United States, the European Union, we're a global industry, other countries to try and put an integrated technology, today's technology into that system. We also need it to be appropriately funded to ensure that when you're up in an airplane and the global air traffic management system has the latest technology that your iPhone has. Seems reasonable. Now, what that comes down to in terms of improvements to carbon footprint, for every 1 minute we shave off the average flight, that's a savings of nearly 5 million tons of carbon emissions. Pretty amazing. Of course, that translates to better fuel and reduced fuel use, so lots of dollars and cents. So, with the budget crisis in the United States, with the debt crisis in the European Union, it's going to take some time. It has taken a lot of time. We've got a lot of folks working together to try and kind of move this through the budget mechanisms around the world. But there's things we can do today. And so let me show you a little bit about what we're doing and our engineers are doing today to try and help this.
When an airplane prepares to land, the wind can be a big factor. It affects where you set the descent point, which path to take, how much fuel to use. Unfortunately, nature can be very unpredictable.
Yeah, it's quite common for the winds to change.
Veteran pilot Brian Holmes says it's an issue all airlines face, and it doesn't help that flight paperwork is often printed an hour or more before departure.
By the time we actually get to the descent point, the wind information could be 6 to 8 hours old, potentially even older than that.
With an outdated forecast, a pilot might use more thrust than necessary, wasting fuel. But a new service called Wind Updates from Boeing Flight Services has solved the problem by delivering real-time information to the flight deck.
So right now we're at 38,000 feet.
Captain Holm is inside a flight simulator to show us how it works. His company Alaska Airlines and KLM have been using wind updates for months to save fuel and reduce carbon emissions.
We're about 66 miles from our top of descent point.
At the start of this simulated flight to Seattle, the forecast had predicted a strong headwind on arrival. But on the ground, the winds have changed. Boeing's computers, which constantly track the latest conditions, start devising a customized update for the flight.
It'll smartly select from that forecast what's the most optimal input of altitudes, of wind speeds and directions and temperatures to make the rest of the flight be the most optimized.
Boeing then sends the advisory up to Captain Holm in the flight deck via the data link system.
We'll press load, and it's showing a much lower headwind.
With the push of a button, Captain Holm accepts the update and the flight management computer automatically adjusts to the lighter headwind, so the airplane begins the descent sooner, burning less fuel. Results from operational trials have been encouraging. Boeing projects airlines will save up to 200 pounds of fuel per descent for a single-aisle airplane and as much as 300 pounds for a twin-aisle jet. Multiply that across an entire fleet and you get significant savings.
Especially now with the rising cost of fuel prices, it's an economic impact to us. The more we can do to conserve fuel, the better it is for everyone, both us and the environment.
The subscription-based service is available for Boeing, Airbus, and other major jets and uses existing equipment, meaning minimal upfront cost.
An airline that starts using wind updates today is saving dollars tomorrow?
It just makes my job easier. You know, the more accurate information I have, the better I can program the flight management systems and helping me to fly the aircraft more efficiently and more precisely.
So, cleaner, more efficient airplanes, more efficient operations, and now sustainable biofuels. That's the 50% mark. So when we talk about fuel life cycle and when we talk about biofuels, we're talking about the amount of carbon that is used by the plant as it grows, the amount of carbon that is emitted during the harvesting and logistics and processing, and then of course the amount of carbon that's emitted during the combustion in the power plant. So over the past 3 years, we've conducted all kinds of biofuel tests and all kinds of platforms, both military and commercial. We've engaged agricultural interests, something that you don't normally think of in the aerospace industry. Of course, leading universities like the UW, fuel scientists, refiners, and of course, the governments and government policymakers. And in fact, how many of you know that the University of Washington just got a $40 million grant to look at growing biofuels, look at how we can take poplar forests and move them into biofuels? Did you know about that? Of course you did, yeah. So that's pretty cool. In fact, UW and WSU were the lead grants. The WSU also got a $40 million across all of the grants that the Department of Agriculture gave. Okay, so what the tests have shown is that sustainable biofuels meet or exceed all fuel performance requirements. They can be used without any change in the platform or the engine or the propulsion system. And that, this is really important, they can be blended with a petroleum-based jet fuel. In July, real important standard got approved that we can use 50-50 biofuel blend with jet fuel in commercial aircraft. So in fact, in Europe, if you happen to take a KLM flight or a Lufthansa, you might just be flying on an aircraft that has a partial biofuel blend in the engine today in revenue service. And last month, the Blue Angels conducted, this wasn't in Puget Sound, unfortunately, but conducted an incredible performance, and they used on all 6 of the F-18s, another Boeing product, a 50-50 biofuel blend. So the potential for sustainable biofuels for aerospace is enormous, and it's actually a must-have for us to be able to grow sustainably. So let me show you another video. This is about biofuels.
Why buy diesel fuel when you can harvest your own? A few years ago, 5th-generation farmer Steve Camp decided to grow some camelina on his ranch a few hours outside of Seattle.
It doesn't need a lot of moisture to grow.
These days, he presses the camelina seeds into biofuel, producing enough to power his whole operation.
This can be done. You know, it really can be done. At this point, I'm very encouraged. I think it's a very viable project.
Steve is not alone, and 2 new studies have found that locally grown biofuels can become a viable industry to fuel air travel. In the U.S., a study by Sustainable Aviation Fuels Northwest, a group that includes Alaska Airlines and Boeing, found the Pacific Northwest region shows potential for growing oilseeds like camelina and deriving fuel from forest residue, algae, and even solid waste. Meanwhile, down under, Australia's National Science Agency predicts that over the next 20 years, an aviation fuels industry in Australia and New Zealand could cut greenhouse gas emissions by 17%, create more than 12,000 jobs, and reduce Australia's fuel imports by $2 billion a year.
Sustainable aviation biofuels are really a key to the growth of the industry.
Bill Glover, Boeing's Vice President of Environment and Aviation Policy, says numerous test flights have already shown biofuels perform better than traditional jet fuel. Now the challenge is to ramp up production, and Glover says local is the way to go.
It's our belief that local and regional efforts are going to be the way that this gets going, because feedstocks vary, geography varies, public policy varies.
Industry leaders say it's on the public policy front where they need the most help to establish a flight path for a sustainable industry.
It's almost like a new industry, and we need some early policy support to get this moving, to encourage the investment that's going to be required and build the infrastructure so that we do have an alternative fuel available at a competitive cost.
Bill Ayer, CEO of Alaska Airlines, says compared to cars and trucks, airplanes have fewer energy alternatives, so a steady supply of sustainable biofuels can't come soon enough.
Fuel is now our #1 expense. We've done a lot with efficiency, with a new fleet of 737s, but efficiency can only go so far. And so we need to look at this alternative source of jet fuel to continue that progress.
In 90 days total growing time, you should have yourself a harvestable crop.
Steve Camp says he's now a firm believer in renewable sources of biofuel, but he's just one farmer. More people will have to dig in for the effort to really get off the ground.
It'll take a whole lot of acres of oil seeds in order to be able to do it 100%, but we can certainly make a huge dent in it.
So, agriculture and aviation, strange bedfellows. So I'm going to finalize with talking about that end-of-life piece of our value stream and closing the loop. So a few years ago, the Boeing Company and others started an organization called the Aircraft Fleet Recycling Association. And this is made up of companies that have to date recycled more than 7,000 military and commercial airplanes. And that's just the start. We've launched programs in the universities in both Europe and the United States to design aerospace parts and tooling out of recycled carbon fibers. 3 weeks ago, a team of our Boeing engineers in our Spain Madrid research facility introduced some side panels that are made out of flax, out of plant material. One of the neatest things, and the thing I kind of get most excited about, are rugs, carpets. So we have teamed up with a rug manufacturer who has patented a recycling process that allows them to recycle airplane carpets. So it's being tested at Southwest on 737s at this time, and the results are terrific. We're looking to maybe offer that, allow that offering to all of our airline customers. So how many of you have been on an airplane over the last, let's say, 6 months? Wow. Okay, well, you know, the carpet, and I don't know how many of you spilled anything in the last 6 months on the carpet. Me. So, hey, those airplanes cover a lot of people, and there's a lot of traffic on, there's a lot of spills. So the average carpet is replaced, how many times do you think in the life of an airplane? 20 to 30 times. 20 to 30 times. On a 777, that's nearly 20 tons of waste that go to the landfill, because what's an important criteria for anything that goes inside an airplane? Flammability resistance. So those kind of materials don't exactly biodegrade easily in a landfill. So we've designed a cradle-to-cradle solution that keeps carpeting out of the landfill, allows our customers to save money by only replacing a portion of this carpeting. So it's really neat. Instead of having to put the airplane down, you can imagine what it takes to take the whole carpet out. Sometimes you got to adjust the seats and put new carpeting in. That's time, which translates to money for our airline customers. We can take patches now because of this technology and just remove the patch. So think how quick we can do that, and then send that to the same carpet manufacturer and bring it back into the raw material for the carpet that goes back in the airplane. We call those cradle-to-cradle solutions. Cradle-to-cradle is very new to us. We're just moving through that. But a couple years ago, biofuels was brand new. Hydrogen-fueled flight, that size of an airplane was brand new. So, in closing, so that we can have some good questions, I hope you're warming up. Engineering has really driven the aerospace industry. And engineering is going to be what drives innovation, to drive the aerospace industry and allow for responsible, sustainable growth in a fantastic market, 5% growth year over year. The distance that the Wright brothers covered in their first flight many, many years ago, and this is a 747-800, brand new airplane, was less than the length of this 747-800. And I can guarantee you that its payload range efficiency for fuel was abysmal. Now, it had a 12 horsepower engine, so I'm not quite sure how noisy that was, but you get the message. So thanks to generations of engineers who've pushed the design envelope, you can see how far the aviation industry's come. And thanks to engineers, this is what's going to take us into the future. Our airplanes now, comparatively speaking, fly all over the world. They fly faster, they fly much more quietly, and they basically sip fuel. Sometimes on descents, they don't even need to be using the throttle. So this is going to allow the future for aviation, and it's in the hands of us engineers. It's environmental thinking has been in the DNA of aviation since day one, and it'll continue to be at the core as aviation grows. So thanks, and I look forward to some really provocative questions. Thank you.
Great, thank you. So the one thing I noticed is when you're talking about the energy source, which is changing to biofuels, you didn't talk at all about the potential for a hybrid vehicle. Meaning that and I know there's because we had a program here at Mechanical Engineering on energy harvesting, mostly through mechanical systems. There's also energy harvesting. You're above the clouds. You have tremendous sunshine. You had a lot of surface area. And clearly, these are not going to be the primary power sources. But again, they can be in these percentages which make a difference. So why are there programs associated with that?
Yeah, absolutely. There are some things associated with solar that we're actually you're going to hear a little bit about on November 9th, associated with some of the long-term research that we're doing. But of course, that is not going to get today's airplane up in the air. So in terms of electrification, when we think about the options for alternative fuels, and we think about the transportation industry as a whole. Ground transportation, electrification is by far the most efficient, right, way of moving and replacing petroleum fuels. We don't have that option in the near term for airplanes. And that's why these biofuels are so important to us. We think that in the biofuel area, so if you think about biofuels for aviation, and we always use the term sustainable because that is job one. It's got to be a sustainable biofuel. But we've got very rigorous requirements for fuel in aviation, and much more rigorous than what you see for ground transportation. And of course, we all know why that is. There are, 1,600 airports, major airports around the world. So think of them as gas stations. There's like 1.6 million gas stations in the United States alone for ground transportation. So it's becoming more and more of a realistic niche to go to the next step would be to the biofuels. Now, long term, hydrogen, it'll be a long time, and Tim's going to talk about that, before hydrogen is going to power commercial airplanes for us. So, yes, but they're much longer term.
Okay.
And we need something, like I said, the aviation industry is committed, so a whole industry has committed to the United Nations that we will move towards carbon neutral growth after 2020. We've got to have solutions because of the tremendous growth in aviation and commercial travel.
So is the new 737 a big improvement from the old 737?
Well, yes. Now, the current 737 is a magnificent airplane, and it offered about a 30% fuel improvement over the prior generation. But the new one will be even better, and it'll be more like a 10 to 12% improvement. Again, we're in the early stages of flight, but our design, and of course that's a new engine, and we're working really closely, as we always do, with our customers to figure out what creates value in their business model.
Okay. And the last question is for me. I just came back from about a 10-day multi-city trip to the East Coast, and I came back with one honker of a cold. So we're talking about aircraft and the environment. So what about the internal environment? Is there plans for that in any of the planes? I asked Rao, I asked a little bit about that before, and it wasn't very satisfying, the answer to a bioengineer. So
well, you know what? We ought to bring you over, and you could help us design some of those things. So I can imagine, because I travel all the time too, when you're sitting in that seat and touching, just like when you're sitting in the theater, or perhaps in the University of Washington Kane Hall, room 210. Yeah, right, proximity is an issue. Now, of course, anywhere further away from the seat in front of you, the seat behind, besides being that close proximity, the air gets recycled and cleaned up. So it's about proximity. And so anytime you're next to somebody, real close,
I already did
like that.
I already did it. I already got my bug for the fall.
Oh, okay. Well, I'll give you my flu shot.
So let's thank our speaker again for a great talk.